video, we're going to learn how to model with geometric series. Here's our first problem. A virus is infecting a computer. In the first minute, the virus infected 6 files. In the second minute, the virus infected 12 more files. In the third minute, the virus infected 24 more files. If this trend continues, how many files will the virus have infected after 10 minutes? So let's write down this information. In the first minute, the virus infected 6 files, so 6. And then in the second minute, the virus infected 12 more files. So the next term is 12. And then after that, the virus infected 24 more files. So 24. And we want to keep going with these terms up until we have 10 terms total. Now you can tell this is a geometric series because we're multiplying by the same thing every time. 6 times 2 makes 12. And 12 times 2 makes 24. So we keep on getting the next term by multiplying the previous term by 2. Now what we really want to do is we want to add up all of the terms in this series. We want to find out how many files in total did the virus infect after 10 minutes. And we know that the sum of a geometric series is given by this formula. Sum equals a1, the first term, times 1 minus r to the n. R is just the common ratio, in this case 2, and n is just the number of terms. That's over 1 minus r. Alright, so in this case, a1 is just 6, because that's the first term in the sequence. So 6 times 1 minus r to the n. Well, r, as we saw, that's just 2, because that's what we're multiplying by every time. So 1 minus 2 to the power of n. And what's n? Well, that's just how many terms we're adding up. And we want to be adding up 10 terms, so n is 10. So 1 minus 2 to the 10th, that's over 1 minus r, so that's over 1 minus 2. So we can just go ahead and put this in our calculator to calculate it. 6 times the quantity 1 minus 2 to the 10th over 1 minus 2 over the quantity 1 minus 2, and the result is that the sum is equal to 3069. So there we go. That's how many files the virus will have infected after 10 minutes. 3069 files. On to the next problem. A robotic vacuum picks up a pound of dust in the first year. However, it becomes slower as it ages, and the amount of dust it picks up decreases by 5% each year. If the vacuum is used for 15 years, how much dust will it pick up over its lifetime? Alright, so why don't we define a sequence here? Let's call the sequence AN, and AN will be the pounds of dust picked up in the nth year. And we want to add up all of the dust picked up from year 1 through year 15. So let's write that down. A1 plus A2 plus A3 plus so on all the way up to A15. Now what's the relationship between these terms? Well, the amount of dust it picks up decreases by 5% each year. So that means to get from one term to the next term, we have to take away 5%, which is really the same as multiplying by 95%. So we can just multiply by 0.95 to get to the next term each time. Great, okay. So we've got a series, and we see that series as a geometric series because the terms are getting multiplied by the same amount each time. So we can just go ahead and use our geometric series sum formula, which is a1 times 1 minus r to the n over 1 minus r. And now we can just go ahead and plug in. So first of all, a1. What is a1? Well, why don't we look back to our information in the problem. The robotic vacuum picks up a pound of dust in the first year. So that's telling us that a1 is equal to 1. So we just go ahead and plug that in. 1 times this quantity, 1 minus r to the n. R we already know, that's just 0.95 because that's what we're multiplying by each time. So 1 minus 0.95 0.95 to the power of n. And n is just how many terms we're adding up. That goes up until a 15, so n is 15. So got that numerator, then the denominator, just 1 minus r. Again, r is just 0.95, 1 minus 0.95. Close parentheses, and now we just have to go ahead and multiply this. We can just punch that in our calculator. The quantity 1 minus 0.95 to the 15th divided by 1 minus 0.95, and the result, if we round to 2 decimal places, we get 10.73. So there we go, that's how much dust it picks up over its lifetime. 10.73 pounds. Here's the final problem. Bert's business is growing quickly. His profits in the first, second, and third years were $128,000, $192,000, and $288,000, respectively. If this trend continues, then after how many years will Bert's business reach $1 billion in total profit? So we've got a sequence here, and A1, the amount of profit in the first year, is just $128,000. A2 is just the next year, so $192,000, and A3 is $288,000. And let's check if this is a geometric sequence. So let's check the common ratio. 192,000 over 128,000 is, if we punch that into the calculator, 192,000 divided by 128,000 is just 1.5. Let's check it for the next pair as well. So 288,000 over 192,000. Punch that into the calculator, and again we get 1.5. So this is a geometric series. We're multiplying by 1.5 each time. Okay, that's great. And we want to figure out how many years will it take for Bert's business to reach $1 billion in total profit. The total profit is just the sum of all the profits for each year, and we want to figure out when does that sum equal $1 billion. $1 billion is 9 zeros after the 1. So let's just go ahead and use our sum formula. Our sum formula starts with the first term, A1, and that's 128,000. So 128,000 times this quantity 1 minus r to the n, and r is just 1.5, so 1 minus 1.5 to the power of n. N is what we're looking for here, that's the number of years, and that's over 1 minus r, so 1 minus 1.5. So that needs to be equal to $1 billion. And we want to solve for what n is here. So first, to simplify the problem, we can just divide each side by 1,000 and cancel out these last 3 zeros. There and there. And let's keep on simplifying. So we have 128, and then 1 minus 1.5 is just negative 0.5. And that's multiplying 1 minus 1.5 to the n. That's equal, again, to 1 million. We can simplify this fraction really nicely by just multiplying by 2 over 2. That'll give us 2 times 128 is 256, and then 2 times negative 0.5 is just negative 1, and 256 divided by negative 1 is just negative 256. So that times 1 minus 1.5 to the n is equal to 1 million. Now we can just divide both sides by negative 256 and get 1 minus 1.5 to the n is equal to 1 million divided by negative 256. And then to get the negative 1.5 to the n alone, we'll just subtract 1 from each side. So get negative 1.5 to the n equals that 1 million over negative 256. then minus 1. To get rid of that negative, multiply both sides by -1 and get just 1.5 to the n is equal to negative times this fraction cancels out the negative in the denominator, so we just have 1,000,000 over 256 and then plus 1. We can simplify this a bit more. This is just 1.5 to the n equals 1,000,000 over 256 plus 1. 1 is just 256 over 256, so add those together, you get 1,256,000 over 256. Alright, let's move that up here to continue our solution. We can solve this using logarithms. N is just equal to log base 1.5 of that right hand side, 1,256,000 over 256. And we can compute that using the change of base formula, so just write it as log of that expression inside the log, so log of 1,256,000 over 256, that over log of 1.5. And that's what we'll put in our calculator, so n is approximately 20.4 years. Now, because the sequence goes by whole numbers, we have to make a choice between 20 years or 21 years. And if Bert's business reaches $1 billion in total profit at 20.4 years, that means at 20 years they haven't reached that yet. So we'll need to choose 21 years for the number of years until they reach $1 billion in total profit. Great, so now we know how to work with finite geometric series, including using them to model real-life situations. In the future, we'll continue to learn more about geometric series, including infinite geometric series.